Hello everyone, myself Jayaditya. I am from ECEB. Today's topic is classification and operations of sequential circuits and flip-flops. Here we can see about exploring the fundamental building blocks of digital memory and sequential logic systems that power, model and computers. Here, sequential circuit. Sequential circuit has two types, asynchronous and synchronous circuit. Here we see the differences of synchronous versus asynchronous circuit. Asynchronous circuit. Asynchronous circuit state changes only on closed edge using flip-flops as array as memory, predictable timing and control. Asynchronous circuit state changes immediately upon inputs, uses latches without clocks, faster response but harder to design. Here state changes only on clock edges. In synchronous circuit, when waveforms are thrown like this, you see that this is the edges. On the edges the clock will open and starts. In asynchronous circuit, state changes immediately upon the input. When you give the input, asynchronous circuits are automatically starts. Uses latches without clock. In a synchronous circuit, clock doesn't used, but in synchronous circuits, clock will be used. Synchronous circuits are predictably timing and control. It was controlled slowly, but in asynchronous circuit, it will respond very fast and have the hardest designs. Key distribution. Sequential circuit possess memory. Their output depends on both circuits inputs and the past states, enabling complex behavior and state implex. In this past state and present inputs are present in asynchronous and synchronous has the present state only. NAND and NOR latches, basic memory elements. Here NAND and NOR are the latches. We see the NAND latch. NAND latch. Crosses coupled NAND gate. Active low inputs S bar and R bar. Byte bistable output storages. NOR gate, NOR latches, crossed coupled NOR gates, active high inputs S and R maintain stable state. Here you see that active low inputs in NAND gate and active high inputs in NOR gate. Here S and R are the inputs and S bar and R bar are the complex conjugates of S and R. If you see further in the next slide. Flip-flops. Flip-flops. Edge trigger storage elements. Flip-flops are the edge trigger storage element. If you see here, some a waveform is here present. These are the edges. In these edges, just the triggering and storing the elements are present. In here, there are some different kinds. Clock control. Output changes only on clock edges, rising or falling, provided synchronously. Outputs are given. When the waveform is occurred, is the output will stored at the end of the edges. Like that, if you see one of the input is rising or falling. If you see here, here is the rising part and here is the falling part. In this both ends we can store the outputs, and four main types of flip-flops are present. RS flip-flop, JK flip-flop, D flip-flop and T flip-flop. Offers different inputs configuration and behaviors. Both all the flip-flops are different in working principles. Asynchronous overrides. Present present say present state is called set and the clear is called reset. Inputs override input override normally operations for the initially. It is also called as SR flip-flop. Building blocks. Flip-flops forms the fundamental of all synchronous sequential circuits and state machines. If you see here, SR flip-flop, operation and truth table. The SR means SR, reset and set. Flip-flop is the fundamental building block with set, reset and clock inputs. Here we can use the clock inputs also. Asynchronous represent preset and clear terminals. If you see here, S and R are the inputs 0, 0, 0, 1, 1, 0, 1, 1, and clock is on state. When, when clock is on state and S and R inputs are both are 0, the next level is Q. The next level gives the input, you give the present state, and if S is 0 and R is 1, clock is on when present state is 0, and next S is 1, R is 0, clock is on, next state is 1. If both S and R are 1, then it takes as invalid description, no change, reset, set, and forbidden state. Mm. Excited state of SR flip flop, when current Q and next state to Q takes inputs 0, 0, 0, 1, 1, 0, 1, 1. If you see current and next state are 0, 0, the SR flip flops S and R both are equals to 0, and current and next are 0, 1. Then S becomes 1 and R becomes 0. When current is 1, next is 0. Then S becomes 0, R becomes 1. Both are 1. In this case, S and R are both are 0. JK flip-flop. If here we can see the JK flip-flop operation. The JK flip-flop resolves the invalid state of RS flip-flops by implementing the toggle functions when both inputs are 1. It is mostly very versatile flip-flops. Characteristic truth table. J and K are the inputs 0, 0, 0, 1, 1, 0, 1, 1. Clock are on state. When clock is on state, J and K are both are 0. Then the next state becomes Q. It becomes hold. And J and K are J is 0 and K is 1. Then next state is 0. It will becomes reset. Then J is equal to 1, K is equal to 0. It will, next state is 1. It will become set. Both are 1, 1. Then it gives the Q bar toggle. reverse are the reverse of the present output. Next, excited table, current and next 0, 0, 0, 1, 1, 0, 1, 1 are the inputs and inputs of present and next stage. Then the JK flip flop output gives 0x 1x x1 x0. Here x represents the 0 and 1 both cases. When current and next state are both are 0, then JK gives 0, 0 or 0, 1, like that. Like that, 0, 1 gives 1, 1, 0 or 1, 1. 1, 0 gives 0, 1 or 1, 1. 1, 1 gives 1, 0 or 0, 0. T flip-flop. T flip-flop operations and truth table. The T means toggle. The T flip-flop is the derived from the JK flip-flop by connecting J and K to a single T input when T is equal to 1. The output toggle when T is equal to Q. It holds state. You see here, T is equal to 0, clock is equal to an. It gives hold Q state. Ante it means present state is the output. When T is equal to 1, it gives the Q bar toggle state. Here is the excited table. Your current and next are 0, 0. Then T flip-flop gives output as 0 and 0, 1 it gives 1, 1, 0 gives 1, 1, 0 gives 0. The excited state of T gives approximately or samely like that XOR gate. D flip-flop. The D flip-flop operations, if you see here, the D means data. Data flip-flop is the simplest and mostly wide using flip-flop. It captures the input data and transfer it to output Q on the clock edges, completely eliminated invalid states. If you see here, characteristic truth table, D D is the input 0, then the next state is 0, it means reset. D has 1, the next state is 1, it means set. The excitation table is Q current and Q next. Current and next both are 0, then D flip flop gives output as 0. Current equal to 0, next equal to 1, then D flip flop is equal to 1. Current equal to 1, next equal to 0, D equal to 0. Current equal to 1, next equal to 1, then D is also 1. Reset and clear terminals in the flip-flops. Reset and clear are the two terminals mainly present in the flip-flop. If you see preset or set, a synchronous force when Q is equal to 1 independent on clock signals override all the normal operations for immediate state initialization. When it gives Q is equal to 1 and the flip-flop doesn't depend on the clock signals, then the preset is used. Clear or reset. Asynchronous forces Q is equal to 0 independent and clock cycle essential for system startup and reliable initial protocols. A clear is used when Q is equal to 0 and the flip flop does not depend on the clock signal, then it is used. Next, active levels can be active low standard or active high depends on the circuit signals. Using active low to the present accidental activation. Critical applications used in initial or override flip-flop states in complex sequential circuits ensure predictable startups and behaviors. Summary and key aways. Here we can learn about it. We can see the further slides of about all the slides in the slide. Here we can see that classifications. Sequential circuits, synchronous, clocked versus asynchronous, level triggered with memory capability. We can see the first slide, synchronous and asynchronous differences and both. Next, flip-flop types RS, JK, T and D differ in behaviors. JK flip-flop is a universal flip-flop. Each serves specific applications require and control inputs. Present and clean provide asynchronous controls for reliable initialization and system operations. Memory elements NAND and NOR latches provides basic storage, flip-flops and clock controls for the synchronization. Design tools, trust and excitation tables guide systematic designs and analysis of sequential logic circuits. Master essential. Deep understanding of this concept is fundamental to design robust, reliable digital system. If you understand in deeply, this will help in creating robots, etc. Uh, you see the flip-flops of all the flip-flops of operations, truth tables, excitation table. But JK flip-flop is the universal flip-flop. It is used in anywhere, anywhere else. Thank you.